open-hole fishing involves the removal of unwanted objects from the wellbore. The objects can be tools, equipment, and broken pieces of drill pipe, bits, or tubulars. Open-hole fishing begins following a back-off in the drill string at or above the stuck point of the fish in the wellbore, leaving an accessible fish top. The fish can be removed using special tools and techniques. A screw-in sub is one of the most common fishing tools. Its modified pin can be used to catch an undamaged fish. The overshot tool, because of its versatility, is frequently used in fish recoveries. Its simple design includes a circulating and releasing action, as well as a 360-degree catch of the fish. Normally, the overshot or screw-in sub is connected to the bottom of the bumper sub and fishing jars on the fishing assembly. As the tool is lowered over the fish, the top of the fish passes through the tool into the bowl. When the assembly is raised, grapples engage the fish at a lower point, and it is worked free and pulled upward. If the top of a fish is bent, twisted, or broken, it should be dressed off to provide a clean top, so the grapple can secure it firmly. Dressing off is achieved with a skirted or hollow-fluted mill. Several types of mills are available for this purpose and other jobs. In a washed-out hole, use of a hydraulic knuckle joint located above the overshot kicks out under pump pressure to increase the sweep of the overshot to facilitate capture of an elusive fish. With a severe washout, a wall hook guide run on the bottom of the overshot further improves the search and capture of the fish. When the fish cannot be dislodged by pulling with the overshot, a jarring assembly run in the fishing string can be activated to strike heavy blows, either up or down, on a stuck fish to free it. The down action is achieved with a bumper jar, essentially a slip joint with a sliding stroke. The impact, enhanced by the weight of drill collars above the bumper jar, results in a sharp blow with the fishing string. Dropping the string quickly produces a sharp downward blow on the fish. This jarring action is especially effective in freeing key-seated pipe or a string that is stuck as a result of an upward pull. In many cases, a stuck fish will require a powerful upward jar to free it. Hydraulic fishing jars permit an upward impact. The impact produced by a hydraulic jar depends on the amount of pull taken on the tool before it trips. As indicated earlier, the impact of a hydraulic jar is enhanced by the weight of drill collars placed above the tool. A jar accelerator further intensifies the effect of a jar at any depth. It is especially effective in shallow fishing operations where elasticity present in longer drill strings is not available. The use of an accelerator also keeps the energy of the jar impact from being lost uphole. When a fish is stuck and cannot be jarred or worked free, a widely used practice called washover is employed. The washover operation is the most successful way to free a fish and requires expert judgment both in pipe selection and in its proper running application. As mud and hole conditions are critical, in many cases a bit trip may be necessary to condition the hole prior to running the washpipe. Essentially, washover operations involve a pipe string that slips over the stuck fish, allowing fluid to circulate in the annulus between the fish and the inner wall of the washover pipe. Fluid under pressure flushes out debris cut loose by the rotary shoe run on the bottom of the washover pipe. The washed over fish, secured by an overshot or screw-in sub, can then be backed off and removed to the surface. The washover pipe selected requires an inside diameter large enough to accommodate the fish and an outside diameter that can rotate without sticking in the open hole and still allow circulation. Various types of Weatherford rotary shoes are available. Each shoe is custom designed for a particular procedure. Tooth-type shoes, for example, are recommended when the formation to be cut is relatively soft. When metal, such as tool joints or stabilizer blades, must be cut, the rotary shoe is dressed with tungsten carbide or diamonds, internally, externally, or both, tailored specifically for the task. Proper rotary shoe selection requires expertise. An improper choice could severely damage the fish, complicating the recovery operation. Occasionally, the drill pipe may be plugged, usually by mud. Cutting the freed drill pipe with a mechanical outside cutter run on the washpipe will remove the obstruction and establish a clean, workable top. Following washover, the washpipe is pulled up and the shoe removed and replaced by a mechanical outside cutter. Run into the well and over the freed fish, the cutter is engaged. With a slight upward strain, cutter knives are fed through the wall of the drill pipe fish, and the fish is parted. Rotation is then stopped, and the cut piece of fish is recovered and pulled to the surface. When the fish is stuck off bottom, a washpipe spear may be run in conjunction with the washpipe and screwed into the fish prior to the washover procedure. This prevents a fish freed by the washover operation from dropping to the well bottom and damaging the well bore, drilling string, or drilling bit. Open hole fishing also involves the retrieval of junk at the well bottom. Junk is defined as any unwanted material in the hole that hampers operations, such as accidentally dropped tools, metal debris, and parts of equipment, including cones from drill bits. A commonly used retrieval tool is the fishing magnet. Fishing magnets are especially cost-effective for retrieving smaller ferrous objects, such as bit cones, slips, and mill cuttings. Permanent magnets have circulating ports around the outer edge so that fill and cuttings can be washed away, exposing the junk for proper magnetic contact. Magnets are furnished with flush guides, lipped guides, or mill guides, which help in washing and securing the junk. The magnet is lowered to the well bottom while circulating and then pulled to the surface. This activity may be repeated until the well bore is cleared of all junk. Where junk pieces cannot be caught by a magnet or consist of non-ferrous metals, Weatherford employs specialized junk baskets, depending on the type of formation encountered. These retrieval tools consist of 3 basic types. The simplest to use is called a boot basket. It is run directly above a junk mill or a rock bit that cuts the junk into small pieces. Fluid circulation deposits these pieces into the basket, which is raised to the surface. In soft to medium formations, a coring type basket, commonly known as a globe basket, can be run to cut a short core in the bottom of the well. This core, as well as any junk contained in it, is held in place by retaining fingers and removed to the surface. In hard formations, a jet-powered or reverse circulating basket is a highly effective tool. Lowered to the bottom, it rotates slowly with circulation to flush settlings from the junk. A ball is dropped into the drill pipe and pumped down until the ball seats in the retriever. The flow of the fluid is diverted to outside the tool, which causes 2 things to occur. It establishes reverse circulation and a venturi effect, which then creates a partial vacuum inside the junk basket. These 2 forces propel the junk into the basket. Captured junk is secured by hinged retaining fingers. This action continues until all junk is removed from the hole.